Hello Math 7 students, this is Open Up Resources Unit 2 Lesson 5, 2 equations for each relationship. To get started, we do have kind of a little fun pattern exercise here. I've given you the second and fourth patterns, I've given you the second and fourth figures in a pattern. We're going to start by figuring out what does figure 1 and figure 3 look like, and then use that to describe, not draw, but describe what the 10th figure in the pattern would look like. Online learners, pause the video now to give yourself a chance to think through this and get that done. And we're back. Figure 1. I hope that you understand that figure 1 is going to look something like that. Yeah? And figure 2 is going to look something... Yeah, that one. Figure 3 would look something like that, yes? And so figure 10, please describe what figure 10 would look like. Jada, give it a shot. Hold on a second, Jada. I apologize. And I apologize to the online learners who have to listen to this too, but we're having some behavior management issues in class. When we have a speaker, there should be only the one speaker. We should be giving our attention to Jada. Jada, please continue. Exactly. Figure 1 is one of these blocks across. Figure 2 is two of them across, but one of them's kind of flipped. Figure 3 is 3 across, and we're kind of alternating that flippage there. So we're going to continue on with that pattern again and again, and I'm really going to take advantage of technology here to show what that's going to look like. Oh, come on. And technology still doesn't love me. Nope, it's not working. What figure is that one? What do I have so far? Emma? Double check. Double check. Figure 6. And this would be figure Shandon. And now this is what figure 10 would look like. Again, we've got 10 across with every one of them alternating upside down. Okay, yes, Hayden. Sorry? Oh yes, this one is 10? Yes. Okay, and now we're going to move on to the actual equations part of our lesson. Again, remember this lesson is called 2 equations for each relationship. Our last couple lessons have been on finding equations. And now we're going to look at the same relationship 2 different ways and see that we can write 2 equations. We've seen problems like this before where we're going to be comparing centimeters and meters. So we start with the information that there are 100 centimeters in every meter, and that is the information that has been placed into the table for us. Right here. So use that information to fill in the rest of the table. But wait, because I'm going to give you a lot to accomplish in this next step. I need this table to be completed, but I also need this table to be completed. So we see that same information, 100 centimeters in every meter, 100 centimeters in every meter. So the same information, compare first. What's similar and different between these two tables? Do you notice how this one starts with meters and then goes to centimeters? This one starts with centimeters and then goes to meters. And we're using different numbers, yes, but that's the main thing that I want you to observe, is that we've got a column of meters, a column of centimeters, and then they've been switched for this next one. The next thing that I need you to do is, it says for each table, find the constant of proportionality. And guess what? You have to find the constant of proportionality in order to complete the table anyway. So that's already a step that you're taking. And then I want you to answer the question, what is the relationship between those 2 constants of proportionality? That's a lot to accomplish, but I bet you can do it. Online learners, you're going to pause the video until those 3 things have happened. Question 1, 2, and 3 are answered. You can resume the video once you've done those things. How does a 1 change to a 100? Jada. So what am I doing every single time on this table? That makes it nice and easy. We can plug these into our calculator, or hopefully you guys remember that pattern that we discussed a couple lessons ago. Really all we're doing is moving the decimal place, and that makes it nice and easy. So 94 hundredths multiplied by 100 gives me what, Dakota? 94. And 1 and 67 hundredths multiplied by 100 gives me what, Luke? Yep, you got it. And 57 and 2400ths multiplied by 100, Hayden? 5,724. And what about when I have an x instead and I go across the table and multiply it by 100? I get what, Chandon? Yeah, either way. You can say x times 100, but even better, 100x. Either way would have worked, yes. Now, what about this side? How does a 100 change to a 1? How does that 100 change to a 1? Sam? Yes, you are right. And which one do you think I'm going to prefer? Yeah, I want you to multiply. Always focus on that multiplication because down here we're asking for the constant of proportionality. So happy you recognize both relationships because if you see that we're dividing by 100, that helps you understand that we are multiplying by 1/100th. You can write it as the fraction 1/100th. You can write it as the decimal 0 and 0/100th, 0.01. Either one is fine. I prefer this one. And when I go across this table and I take that 250 and I multiply it by 1/100th, what do I get? Gavin R. 2.5. And when I take the 78.2 and I multiply it by 1/100th, what do I get? Danny. Yeah, thank you for fixing that. 0.782 or 782 thousandths. And when I take this 123.9 and I multiply it by 1/100th, I get what, CJ? 1.239 or 1 and 239 thousandths. So, we're not surprised that I'm going to take this y and multiply it by 1/100th and I get what? Trinity. Yes, but what's the better way? We always like that number to be at the beginning, right? And so yes, it would be y 1/100th, but that's a weird way of saying it. And so instead I would say 1/100th y. Yep, that's going to be the better way. You could write it as y times 1/100th. That's okay. Just like you could have written this x times 100. That's okay too. Mathematicians are just picky and lazy, and so we like it to be in this order instead. But I would not mark it wrong if this is what you wrote down. What is the constant of proportionality? We literally had to find that in order to be successful with this problem and fill out that table. What is the constant of proportionality for this one, Hagen? 100. What is the constant of proportionality for this table here? Have I called on everyone with their hands up? Ah, Berkeley. Yes, and while that is true, the next question is almost impossible to answer if we leave it like that. So let's answer it this way. Even though you might have typed into your calculator times 0.01, we know that that's the same as 1/100th. And the reason I want to focus on that is because it says, what is the relationship between these constants of proportionality? And if you write it as a decimal, you're not going to see that relationship. What's the word? We can answer this with one single word. Emma? Reciprocals. Reciprocals. 100 and 1/100th are reciprocals. Now, for each table, write an equation. And again, you have already done like 99% of the work here. When we read, it says for each table, write an equation for the proportional relationship. Let x represent a length measured in meters. So here's a length measured in meters. What label are we going to give this column? Read it again. Let x represent the length measured in meters. So what am I going to give this column? What label? X. And I see another column that says length measured in meters. That one is also going to have the label x. Keep reading. And y represents the same length measured in centimeters. So I see a length measured in centimeters. That's going to have the label y. This is going to have the length or the label of y. So when I start in this column, I go across the column by multiplying by 100. And that gives me 100x. But if I look at it up here, when I take that x, uh-oh, my cursor disappeared. When I take that x and go across the table by multiplying by 100, I end up with y. There's your equation. Again, it's just that simple. X multiplied by 100 is equal to y. Start here, go across the table, end up here. And as we've mentioned, can we reverse this and say things like y equals 100x? Yeah, your choice, whatever you prefer. Now what about here? Same idea. This time I'm multiplying by 1/100. So I'm going to start in this column here. And when I go forward, I multiply by 1/100th. And when I do that, where do I end up? Right here with an x. So again, it's just that simple. Y multiplied by 1/100th is equal to x. And again, we can always write this in different ways. We can say x equals 1/100th y. And you could also use the 0.01 instead. But here's what I want you to recognize. Again, do you see the constants of proportionality here in our equation? We have the constant of proportionality 100 and the other constant of proportionality 1/100th. And you can also see that right here in those equations, you can see that reciprocal relationship, right? Yes, Mrs. Proctor, I can see it. Okay. Thank you. Compare these two equations then. Is this the only change, is that the 100 became a 1/100th? Look and see if you can find other changes. Talk with your groups real quick. Okay, and here's what I hope you saw. Here in this equation, the y is all by itself, and the constant of proportionality is multiplied by x. But here, the x is all by itself, and the constant of proportionality is multiplied by y. Do you see how those variables switch places too? Okay, and now we're on to the next problem. We're not going to finish this problem today, but we are going to do enough to get started, and here's the takeaway. Over here on this problem, I hope that you saw that fractions are friends. Because when we keep our constant of proportionality at fractions, we can see that reciprocal relationship. So we are going to understand that fractions are friends here on this problem. So to get started, it reads, it took Priya 5 minutes to fill a cooler with 8 gallons of water from a faucet that was flowing at a steady rate. Let W be the number of gallons of water in the cooler after T minutes. To get started on this, when I look down ahead, looks like we're looking at equations. And since we're looking at equations, the only time we have ever written an equation is when we have started with a table. We don't have a table for this problem. However, we can make a table. When I say make a table, these tables here are tables that are done by the computer. Computers can make nice straight lines, they can do these fancy borders. When we're writing, we don't have the time for that, and we can't do them as neatly. So instead of trying to make a big box with all of these lines in it and splitting it and then having it look terrible because we're not a computer and we can't do it nicely and neatly and evenly, just make a table, also known as a T-chart. So it will just be very simple, and it will look like this. And the information that it gives us is what's going to go into that table. And we've done that before, where we read it, we highlight it, and then we put that information in the table. So here it says it took Priya 5 minutes to fill a cooler with 8 gallons of water. And then when I continue reading, I can see that it says let W, oops, wrong color, let W be the number of gallons of water in the cooler after T minutes. So I've highlighted the 5 minutes, T is minutes, I've highlighted the 8 gallons, and I've highlighted the W representing gallons. And so I'm just going to take that information, I'm going to put it right here in the table. So I'm going to start here with T minutes and finish up on the other side with 8 or W gallons. So now I know what these labels are even going to be because it specifically told me the labels. This is going to have the label T for time in minutes, and this is going to be the label W for gallons of water. And now all we have to do is simply take that information that we highlighted and put it in the table. So 5 minutes, that's a 5. 8 gallons, that's the 8 there. Now, just like in this problem, we had the same information, but then we flip-flopped it to create our second table. That's exactly what we're going to do here. We're going to create a second table. Again, that just means since we're drawing it by hand, it's just going to be a little T-chart. We're going to have the W on one side, the T on the other side. Again, all that I've done here is I've just flip-flopped. T was on the left-hand side, and now that T is going to be on the right-hand side. And the W was on the right-hand side, and now it's going to be on the left-hand side. So I'm going to take that information that was here. The 5 still goes in the T column. The 8 still goes in the W column, but notice that they've just swapped places there. Now, our next step, you might think, well, I don't know how to write an equation. This isn't a very good table, but this is all that we need in order to write our equations. I know that there's not very much in that table. Normally there's a couple more rows of information, and if you want to create those extra rows, you can, but this is all we need to start an equation. Because all we have to ask is, how does the 5 change to an 8? Over here we ask, how does the 8 change to a 5? And again, it's just that simple. Maybe you don't know how the 5 changes to an 8, so we've developed the strategy for that, and that is that we're going to work backwards. The 8 will be divided by 5, and 8 divided by 5 is equal to 8/5. So I know that I will go forward in this table by multiplying by 8/5. Now, I told you fractions are friends, and they are, but we can also see that we've got decimals down below. So even though fractions are friends, this problem will be simpler if we also write that 8/5 as a decimal. And 8/5 as a decimal, go ahead and plug it into your calculator, is 1.6. And here we ask that same question, how does an 8 change to a 5? And if you don't know how an 8 changes to a 5, that's okay. We just work backwards. 5, working backwards to divide by 8, and 5 divided by 8 equals, plug it into your calculator if needed, but remember fractions are friends, so 5 divided by 8 is the fraction 5/8. And again, the whole reason for doing it this way is because now we can see this relationship. How are 8/5 and 5/8 related? Those are reciprocals. That's why it's important to keep them as fractions, but I also want you to make the connection now that here we have 8 divided by 5 is 1.6, 5 divided by 8, because we see these decimals down below. 5 divided by 8, plug it into your calculator, 0.625. And using that, I can now write my equations, where since the 5 is multiplied by 8/5 to turn into an 8, when I have a t, I'm going to follow that same pattern and multiply by 8/5. Or in other words, since 8/5 is the same as 1.6 here, we can also take that t and multiply it by 1.6, and it will be our w. So two equations that we can write here, t times 8/5 is equal to w, and t times, instead of the fraction 8/5, we would do the decimal 1.6 is equal to w. And again, we've written these in reverse order as well. So t times 8/5 equals w, we would write as w equals 8/5 t, or w equals 1.6 t. And here, similar thing, how does an 8 change to a 5? Well, it's because we're multiplying by 5/8. Or if we wanted to use that decimal, we can use that decimal we multiply by 0.625. So the equation here is going to be the W goes across the table, multiplying by the fraction 5/8, and when I do that, I end up on the other side, it's equal to T. Or we can use the decimal, W times 0.625 is equal to T. And again, reversing those so that we can see what they look like when we write them backwards. That would be T equals 5/8 W, and T equals 0.625 W. Now we have taken the time to write our own equations for this situation. What do we do with that information now? Well, the first question is saying which of these equations represent this relationship. So I took this step knowing that we needed to write the equations, and I decided to write the equations so that now I know which equations work, and now I can find them here among that multiple choice situation. So that's it for today. We will finish this problem in the next video, or we'll finish it tomorrow in class. And we've got a little bit more to cover before we get to our summary and our cool down and homework. So no cool down and homework today. We will get there next time. Thank you for watching. We'll see you next time.